All right, this is 2.3 homework. First problem gives us this polynomial. Looks like a fifth degree polynomial. And they want us to answer this question. Here it is right here. It says the graph of f shows blank. How many relative maximum? That'd be 1, 2. And relative minimum, there'd also be 1, 2. And a total extreme one, that'd be 1, 2, 3, 4. There's 4 total. And it's increasing on the bounded interval from here to here. The reason why is because obviously it's increasing from here to here and from here to here, but those are unbounded intervals because they go all the way to negative infinity, all the way to positive infinity. So the only bounded interval where it's increasing is from 0 to 1. I think we've done this problem before, but when you have fourth degree, you can actually factor this one. X squared minus 3 and x squared minus 2. And then set each of these factors equal to 0, so you get x equals plus or minus the square root of 3, and x equals plus or minus the square root of 2 when you do that. And those are your answers once you list them from smallest to largest. All right, next problem gives us these different functions here in different colors, and it wants us to know if they're polynomials or not. So if they are, we'll enter in a p. If not, we'll enter in an n. So the blue one is the reciprocal function. That's y equals 1 over x, which is like y equals x to the negative 1. That's not a polynomial, right? Because it has negative exponent, so that is not. The green one is, obviously, it looks like a fifth degree polynomial. So we'll put a p in there. Purple one, I don't even recognize that function. It's not a polynomial. The red one is a polynomial because it's like y equals 2x to the 0th. X to the 0th is just 1, so it's really y equals 2, which is a polynomial. Right? We can have 0 and positive exponents only. And then the other one is not, that's an absolute value function. So that's not a polynomial. All right, the next problem says you have an aquarium that is 1 foot higher than it is wide. That means the height is the width plus 1. And 1 foot longer than it is high. That means the length equals the height plus 1. That's 1 foot longer than it is high. All right, it also says it holds 6 cubic feet of water, so the volume we know is length times width times height, which we know equals 6 here. So I need to get it. I have 3 equations, 3 variables. This should be a pretty simple one to substitute for. I'll substitute in for, I'll get all h's here. So width equals h minus 1. So I'll plug in h minus 1 in for the width, right? Because I can solve this one and get width equals h minus 1. And then the length is h plus 1. So the length becomes h plus 1. And that'll equal 6. So now I'm going to FOIL the first two. That gives me h squared minus 1 because it's the difference of 2 squares. I still need to multiply that by h. That gives me h cubed minus h minus 6 equals 0. That's my polynomial. Now I just need to graph that and find out what the height is. You can do that in decimals, and where it equals 0 is where h is 2. So h equals 2. If h equals 2, then the length equals 3. And then if you plug in h equals 2 here, subtract 1, you get the width equals 1. All right, this one just wants us to multiply this out. So start with the first two. You get x squared minus 6x, but plus 3 is going to give you minus 3x, and then minus 18. And I still have to do that again with this one. So it's x squared times x, which is x cubed. X squared times negative 10 is a negative 10x squared. Negative 3x times x is a negative 3x squared. Negative 3x times negative 10 is a positive 30x. And negative 18 times x is a negative 18x. And negative 18 times negative 10 is a positive 180. So now you just have to simplify like terms, these ones and these ones. And you get x cubed minus 13x squared plus 12x plus 180 is what they're looking for right there. All right, the next problem wants us to match these. So the first one asks for a quartic binomial, which is the 4th degree. That'd be d actually. If you boil this through, you'd get x to the 4th minus 2x cubed. So that'd be d. Next one is a cubic polynomial. B, if you FOILed it out, you'd end up getting x cubed. So that'd be b. A quintic, which is a 5th degree, is e. The square of a cubic binomial. So the square of a cubic, you know, you'd end up having x to the sixth because when you square outside here, this, you know, you multiply these exponents, so you get x to the sixth, which is a. And then just a regular trinomial, the only thing left is c, and it is true that if you FOIL this one out, you get a trinomial. All right, just some simple vocab then. This polynomial written in standard form is 8x to the fourth plus 4x minus 9, where the degree is the leading exponent, the highest exponent when it's written in standard form, and the leading coefficient is 8. So it's the fourth degree, leading coefficient is 8. All right, next problem 8 then, it says find a cubic equation in this, so that's with our calculator again, right? We just go to stat, we go to edit, and make sure that you clear these. And just enter in the L1 your x values, -8, -7, 3, and -5, and enter in your y values, and we'll do stat calculate cubic regression. So stat calculate cubic regression, which is 6. And just go ahead and enter. That should give us that equation. I do have my diagnostic turned on, so that tells me it's a perfect fit. So there's my equation, y equals x cubed. And that b, that's really 0, right? 1.66 times 10 to the negative 10, that's the calculator's way of saying, I guess that's about 0. So we're going to use 0 for b. C is 3, and d is 4, right? 0.9 repeating is really just 1. So this is 4. So I'd have right here. Now, there is a way to do this by hand as well. If you set up a system of 4 equations with 4 variables, you could actually do this by hand by solving that system, which we'll do later in the year. We'll probably do it with second degree polynomials mostly, not cubic, but you can do it by hand. All right, next problem gives us a point that it goes through, and then it shows us this one. Now this is a fourth degree polynomial because it opens down, so, and you know, it's got 1, and then this one has a multiplicity of 2, and so that'd be 1, 2, 3, 4, 0. So our function is, I don't know what the a value is exactly, but it's got a multiplicity of 2 at x, so there's x squared. And then x plus 4 and x minus 2 to get those zeros in there as well. So we know a is going to be negative when we plug this point in. We just don't know what the value of it is. But that's where you can plug in 5 for x now. So 5 goes in for those x's. And negative 472 goes in for that y. And you're solving for a. So it takes a little time to plug this into your calculator. Probably the easiest way is to pull out your graphing calculator. Plug this, nah, never mind, sorry. I think the easiest way is just to go ahead and do it by hand. All right, for me, when I did that, I got negative 7/10 or 0.7 for a. So my answer would be this. Okay, the next problem is a cubic. We know what they look like, and we know that it's always got n minus 1 local maximums and minimums. So in this case, and we can tell that right from the graph, right? We know the answer is 2. So we just say 2 right there. Or you can take the highest degree, you can take the degree of it and subtract 1. All right, this problem gives us the fourth degree. Wants to know the y-intercept. Keep in mind the y-intercepts are where x is 0. So if you plug in 0 for x, you get 0 for y. So it just wants y equals 0 for the y-intercept right there. The x-intercepts are where y is 0. So plug in 0 for y. We already know one of them's at 0 again. But if you plug in 0 for y, then you're factoring this and solving this because there's more than just one answer. Could be up to 4. Let's pull out an x squared from everything. That leaves us with x squared plus 3x minus 28. And then we could solve that. That's x squared times, this would be x plus 7, x minus 3. I'm sorry, 4. And so that would make the zeros 0, negative 7, and 4. And we know what this thing looks like then. It goes, touches at 0 and then negative 7 and 4, so this thing looks like this. And we know it goes up, it opens up. So as you go to infinity, y goes to positive infinity. And as you go to negative infinity, y still goes to positive infinity. All right, next problem 12 then. You look at this. This goes to negative 4 and 4. You can click on it to make it bigger. And then it gives us another point on the polynomial. We know it's a third-degree polynomial. It's odd, but it's also got a negative a value because it's been reflected over the x-axis. So my equation, f of x equals, I don't know what my a value is. I'm going to have to find that. Equals negative 4. So one of the factors has to be x plus 4. And then also, this one over here is 4 is a 0, so x minus 4 must be a factor. But that's got a multiplicity of 2 because the fact that it touches and turns around. Anytime that happens, it's an even multiplicity. So it must be multiplicity of 2, which gives us our cubic polynomial. Now I have to find a, so plug in 5 for x and plug in negative 4.5 for y. And just solve this. 5 plus 4 is 9, and then this would be 1 squared. So just divide both sides by 9, and you get a equals negative 4.5 over 9. Whatever that is a decimal. Negative 1/2 is my a value. That goes in right here, and there's my answer. Okay, the next one gives us a cubic, and it wants to know the roots in increasing order. So the roots are 2, negative 6, and negative 4. So increasing order would be negative 6, negative 4, and 2. And so hopefully we can do this without a calculator. Negative 6 is here, negative 4 is here, and positive 2 is here. Like, you know, that's not perfect, but good enough. And we know it's a cubic polynomial, so we know it must go like this. So it says to the left of the first root, the graph is below the x-axis. Between the first two roots, the graph is above. Between the last two roots, it's below, right here. And after the last root, it's above. Our next problem says the grain silo consists of a cylindrical main part. So there's our cylinder. And then it's got a hemisphere on top. So, and it's got, I'll draw this in a different color, but it's got this half of a sphere on top. All right, so if we call this R right here, that's what we're looking for in this case, but it gives us the volume of this of the whole thing, and it gives us the height here is 30. Okay, so the volume of the cylinder is going to be area of the base times the height, and then we also have to add on half of the sphere, which the sphere's volume is 4/3 pi r cubed. The base is a circle, so it's pi r squared. The height they gave us is 30. The volume they gave us is 15,000. And this would be plus 4/6 pi r cubed. Yeah, so I just need to get this basically in standard form and solve for r. I'd graph it with decimals probably is the best way. In standard form, this would be 4/6 pi r cubed plus 30 pi r squared minus 15,000 equals 0. And then, you know, it's just a cubic polynomial where your variables are. You use x if you want when you go to graph it. But graph it in decimals and go ahead and find r from there. This one's pretty easy then, a third-degree polynomial. Having zeros, so the x plus 7 is one of the factors, x minus 4 is a factor, and so is x minus 5. And they want the leading coefficient to be 1, which means that's just a 1 right there. And there's my polynomial right there. Probably just enter this in. Have it be good. Next problem, you get this, you write out these zeros right here. That one's got a multiplicity of 2. And then one of the points on there is 0, negative 1. So if you plug in 0 for x and negative 1 for y, you get a times 9. And then divide and you get a equals negative 1/9. So that'd be mine. And I'm out of time, so I gotta go quick. But the limit of this function, if you graph it, as x goes to positive infinity, would be negative infinity because the y value goes down to negative infinity. Hope this helps.